Hello, everybody. My name is Alessio Luschi. I am a research fellow and also a PhD student at the Department of Information Engineering at the University of Florence in Italy. And this work is about designing an indoor location system for hospital facilities. The team is made by myself and by Ernesto Iadanza, which is the coordinator of the team. We also have Noemi Falleri and Eleonora Borsani, who are bachelor electronical engineers. Well, nowadays, navigation portable applications have grown during the last years. However, the majority of these applications works only for outdoor positioning and routing, because they rely upon the GPS signals, which cannot be received in an indoor system. So they cannot be received inside the building. They work perfectly for outdoor routing, but not for indoor routing. There are new technology and algorithms that have been developed and adopted during the recent years to face indoor positioning system. These are such as RFID, Wi-Fi, Bluetooth Low Energy, or magnetic fields, or computer vision-based systems, and many others. The scope of this project is to define the best fitting solution and develop a real-time location system for the hospital of Luschi in Siena, here in Italy. The hospital is very complex. It's made out of 12 pavilions, covers a large area, and has more than 8,000 rooms. Moreover, these pavilions are built on a hill, so it's not rare that a basement of a pavilion is directly linked to the first floor of another pavilion. So routing inside this kind of building can be very, very painful, especially for patients and for external persons that come inside the hospital. We designed this system by actually think about two separate systems, one for an on-site navigation and one for an off-site navigation. The off-site navigation system is based on Unity 3D and the nav mesh functionality inside a web application. By accessing this web application from outside the hospital, the users can navigate inside the hospital itself, and from a starting point to a list of this available point of interest for destination, and plan is trip to the hospital. On the other side, we have the actual on-site navigation, which is a mobile application that is both for iOS and Android systems, and has been developed by using the Apache Cordova framework, which is a cross-platform framework that can be used together with third-party plugins. In fact, we use the Google Maps plugin and the Indoor Atlas plugins. We use Google Map for displaying the maps and all the markers that are useful for guide the users during the navigation. And we use the Indoor Atlas framework and APIs to interact with the available signals inside the hospital to get the actual position of the user inside the building. At the time that we made the demo of this application, only Wi-Fi signals and magnetic fields were available inside the hospital, but they can be updated with other kind of signals like Bluetooth Low Energy, for example. These are some of the UML schemas that we use to design the system, in where you can find some routines and some functions that are inside the application itself, together with other routines that rely on the Google Maps framework or the Indorata's framework that I told you before. Here on the left, you can see the user that is outside the hospital, is not in the hospital. So is planning is a visit to the hospitals by selecting a starting point and a destination point from a list of points of interest. The route then can be saved and stored inside the device itself. So there is no communication with the server for privacy problems. And it can add multiple maps, multiple routes to the navigation and store them inside the device. Then the users go, inside the hospitals. Here he is. He can load the routes that he has stored before by using the offsite mode, and then he can walk and route the users to the destination that is saved when he was at home or where he was not in the hospital. You can see that the accuracy is not very good. In fact, you see that the circle, the purple circle, is very wide. That is because when we recorded this demo, as I said, there were no Bluetooth Low Energy beacons installed in the hospitals, but only Wi-Fi and magnetic system. So the accuracy of the position was not perfect, but we also then made some other tests with 3 or 4 beacons installed in the hallway and in the corridors, and the results were very much better. So this is obviously a beta version of the mobile system. Then now we are currently made usability tests on the application for different kind of users in order to improve the user friendability of the application. Thank you very much.